All right then, folks, thank you for that. Now I would like to introduce Danique Wortel, who is the attending veterinarian at Ichor Life Sciences. Has been at Ichor since pretty much its inception a decade ago. Ichor Life Sciences is the most successful by some distance of the half-dozen spin-outs from Sense Research Foundation that we created. It was originally focused just on one project, which actually you're going to hear about from Ichor's CEO. I believe it's tomorrow. But today, Danique's going to talk about the experiment that she's been overseeing. I really lucked out in being able to partner with Ichor Life Sciences to do this experiment. As you've seen, it's a terrifying experiment, and you really need someone who is just completely impervious to being terrified to oversee such a thing. So I'll hand over.
Thank you, Aubrey. Good morning, everyone. I'm Dr. Danique Wortel. I graduated from Cornell University with my doctorate of veterinary medicine, and I've been working with Ichor Life Sciences for 10 years, running mouse lifespan studies. So Aubrey asked me here today to talk a little bit about some considerations for running large-scale mouse lifespan studies, as we're doing with this very exciting LEV study. And just two things before I really get going. First off, I tend to speak pretty quickly anyway, but when I'm very excited about a topic, I tend to speak even faster. So bear with me a little bit. This topic is very near and dear to my heart, so if I breeze through it a little bit, we can absolutely, of course, discuss more things in the panel. The second thing is, as we really move forward about talking some of this stuff in here, I want you to keep in the back of your mind that this is also all going on with everything else that's typically happening in our facility already. All the other studies, all the other everything. So just keep that in the back of your mind there. But first off, I am an employee of Ichor Life Sciences, so I do receive compensation for some of the work that's talked about herein. But breaking the considerations into two general topics, one calling them general study considerations, very exciting title, other one focusing a little bit more on some health-specific considerations. Now, vet school has taught me, at least, to have a very strong stomach in the 4 years of school. However, just note, I do have some graphic images of animal health issues in this presentation. So in the event of an emergency, perhaps stow your tray table and proceed to the nearest emergency exit. To follow up on the brief introductions, as mentioned, I graduated from Cornell, always knew I wanted to do that, and then moved forward to working with Ichor Life Sciences, where we really started working with the aged Black 6 model soon after it actually started being produced by vendors such as the Jackson Laboratory. And that was exciting because that really allowed us to actually work with them to help develop best practices of what to do with these animals right from when they first actually started to arrive in the facility. Just as a brief shout out, I myself am not affiliated with the Dog Aging Project, but those are my 3 dogs at home, and that big guy on the right absolutely is. He was actually the 5,129th member of the pack, so thank you, Matt, for that. Exciting opportunity for him, and definitely looking forward to connect with you otherwise further in the conference. Ichor itself was established in 2013. We're up to about 50 staff members with 25,000 square feet of newly renovated facilities. Our vivarium itself, which is actually the 5th one I've built, is located in Lafayette, New York, just south of Syracuse, New York, and is ALAC accredited. And with that, we'll jump right in. So the first thing I want to touch base on is just animal care staff. So these are the staff that we consider are involved in the day-to-day of the facility. So checking those cages every day, changing those cages, maintaining your facility. And in our case, actually also doing things like body weight measurements or even providing daily supportive care for these animals. Now, it's absolutely critical. And I mean that really. It's absolutely critical that these animals know and how to work with these aged animals and how to interpret their disease states. And so when they're doing those even just those daily cage-side observations, they need to be able to pick up the subtle little signs of maybe that animal isn't really doing so well and needs to be looked at. Even more so when they're doing things like actually handling the animals with body weight measurements or cage changing. It's not like in a young animal where you can really just move that animal over without little concern or place it in the scale and then move it back. But with these aged animals, they're really evaluating them every time that they're handling them and looking at their teeth. Is their skin okay? How is their body condition score doing? And as they start to develop these health issues, a lot of these animals often need daily supportive care so that we can help them along, minimize any pain and distress, and be able to get them a little bit further in these lifespan studies. And while that might mean that these tasks might take a little bit longer for the animal care staff as compared to with young animals, again, it's critical that we even let them have that time, because the animal care staff often have eyes more often on these animals than the technical or veterinary staff. So consider that. And in the LEV study, for example, the treatments were very front-loaded, pretty much in the first 2 months of the study. So in the first 2 months, technical staff had heads on these animals every day. Thereafter, though, until we maybe hit some of those critical time points where we're running behavioral assays again or evaluating those animals again, it's really up to that general animal care staff. They are the first line of defense for those animals in terms of interpreting if something's wrong with them and if we need to be able to start helping them. That then also does create the groundwork, though, where all of the staff really create some pretty emotional connections with these animals. We name them, we really do connect with them, we have some fun. This was one of the LEV mice. We realized it was their 2-year-old birthday, so we had some fun with taking some cute little pictures and things along those lines. It's really, we do really live through this with these animals, working with them this closely. So that really does create the groundwork for some compassion fatigue, which is absolutely a great thing, or a big thing, not only in laboratory animal medicine itself, but especially with lifespan studies. And what we should consider there is, it's not like an oncology model where that staff member is giving that animal cancer, understanding then that that's likely going to cause some secondary effects. Here, there's really no direct insult that we're imparting. We're actually really kind of bringing these animals in and just in a way monitoring them through this entire study. And because you really need that staff with the experience to work with these animals because they're so special, you have a subset of that staff that's doing a lot of this work for a long time, on the order of years, very closely with these animals, watching them slowly decline. So in our facility, we do have a little memorial garden. Very much staff are welcome to help maintain it and things, but in general, it also just is a representation of how much we respect what these animals are giving to us as well. Moving on to the technical side of things a little bit more, it's definitely not performed the same as it is in a young animal. These animals can be more frail, more sensitive to stress and restraint. So one of the things that we thought a lot about with the LEV study was, how can we be administering these treatments? How often do we want to be administering these treatments? Even just in technically performing them, often we're doing that a little bit differently than with a more robust young animal. And if we actually even just consider normal in terms of what a young animal might be, that actually doesn't even apply here anymore sometimes in some cases. So if we look in that picture on the right, represents relatively normal anatomy, especially in the abdomen there. So we have the liver, we have the GI system, and you can't even actually see the spleen as it's nestled right in that, behind that GI next to that stomach. But in the animal on the left now, we can see that it has a very, very, very large spleen. So this animal was euthanized for body condition score issues, which we'll talk about a little bit when we get into the health monitoring things. But it has a very large spleen that's even deviating that liver and that GI system all the way over to the right. So if I'm a technician and I'm going to have to go perform an intraperitoneal injection, or an injection into the abdomen of this animal, I probably can't do that the same way as I do it in my healthy young normal animal. So first off, I first have to recognize this animal appears abnormal. It might have a pot belly. Then I can go and palpate that that spleen is that large and be able from there to dictate, how can I still safely administer this treatment to this animal so we can move forward with the scientific side, but also, again, be safe for the animal. That same animal then, if we consider with that same spleen that had to be euthanized for body condition score, we were monitoring that animal, ensuring that it was still doing okay until it actually had to be euthanized. That doesn't follow a predictable schedule. So it's not always going to fall on a Monday through Friday or a convenient 9 a.m. It might be on a weekend. It might be on a holiday. Who knows? So we need to be able to accommodate the flexibility in your staff and in your scheduling, particularly with the staff that have the experience, again, to work with these specialized animals. So we use a sophisticated Ganting software called Team Gant, which really lets us on a pretty darn granular level schedule what staff member is doing what for and where for how long. So if we need to be able to shift things around because we've had an unpredictable event happen and I need this one staff member who can do this behavioral assay to come in and do that study, then we can do that and staff knows exactly what they need to be doing. These studies are also long-term, again, on the order of possibly 1 to 3 years, depending when you're starting your interventions. So we also need to ensure that we're supporting our staff in terms of making sure we have those good techniques and are allowing for cross-training and also the emotional support so that we can retain these staff so we can run these studies reliably. Now, I'd want to pivot a little bit and just ask an age-old question, but does size really matter? Well, this is Pancake. And so I would argue that for the sake of the lifespan studies, that size is indeed quite important. So he might look like a genetically modified mouse that's meant to be obese, but he's not. He really just is an aged black 6 who just likes to sit there and be a little large. But this not only in terms of animal size, actually the concept of size really matters, has to apply to a lot of things in these studies. And again, as I mentioned at the beginning of the study, keep in the back of our minds that this applies on top of everything else already going on in your other facilities in terms of the general amounts of feed and bedding and work that's going on. But for this study specifically, we have 1,000 mice. They eat on average about 5 grams of food a day, so that comes out to about 840 kilograms of food for just the first 6 months. And again, average of 5 grams of food a day. Well, my buddy Pancake, probably eating a little bit more, so maybe if we're being conservative, then we're actually looking at an estimated 1,000 kilograms or a ton of food for the first 6 months. Do you really want to be storing all that? Do you want to have all that overhead? Can you even store all that? Or do we have to set up recurring shipments with our vendors to ensure that we can have adequate amounts of food at all times? More than likely. Considering if you're formulating a special diet, also depending on how you work with that formulation, that diet might actually even require cold storage, which can just add a whole nother level of intricacies to these sorts of studies. Beyond even just the food, we have to think of some of the other consumables and also consider that vendors may not actually be able to fulfill orders immediately depending on the size of things that you actually need. So for some of these custom diets, for example, you could have a 2-month lead time. So we need to ensure that, again, you're monitoring your inventory, you're able to ensure that you're not going to run out of a critical thing for your study. The LEV study, again, was a fun example of just volume, where we're running glucose tolerance tests on a certain schedule. So for the entire study, that was going to be an estimated 10,000 glucose test strips that we were going to need. Again, do I want to sit on all that overhead? Probably not. Do I want to possibly run into expiration date issues if I buy all that one at once and then I don't need some of it until possibly 2 years out? So again, considering probably needing to be several separate shipments from vendors. As I've mentioned previously, the study was also pretty front-loaded with all of its treatments. So literally in the first 2 months, that required 15,000 syringes. And as we started doing these treatments, the staff kind of started having a fun little thought of just how much volume that actually was in some of the little parts of these syringes. So we started having some fun, and we started collecting the little injection caps off of those to see if we could fill one of those big old water jugs. The study's not over yet, so we'll see. We're still getting there, but that's one of our little goals here, just for fun, what we have with the team. Consumables, of course, but that also applies to the test materials. So that really, the need there can actually really be pretty extreme. So if you look in this little picture, these are just 2 female mice from the same cage, but one is about double the size of the other, and that's absolutely perfectly normal. But if I'm going to go calculate test material needs for a study, then for a young animal, I might consider using about a 25-gram average body weight. For these aged animals, we really need to be using 40 to 50 grams, simply because some of them can be that large. And that really can be a drastic, almost double the amount of test materials that you need in these aged mice lifespan studies compared to young animals. So for our LEV work, for that single stem cell administration, that was about $130,000 just in the mobilization drugs that we needed for these animals. If we also consider that average weight, that also applies to cage space, along with a couple of other things that I'll mention here. So it's really not always what it seems if you're just considering what you might have experience with a young standard animal study. So this is just a little clip from the Guide to the Care and Use of Laboratory Animals. And as we can see, it outlines that based on a certain amount of body weight, animals are required to have a certain amount of floor space. And as that body weight increases, so does that floor space. What does that mean? Well, if I have a young mouse study, I can fit 5 females in a cage, no problem. Might not be the case with these aged animals, where again, we might have double the body weight that we're typically expecting. Other things that can affect cage space is fighting among males. We'll touch base on this in the absolute when we talk about the aged health or the health considerations, but absolutely that's a big cause for additional needed cage space. So in our facility, we only house 3 animals per cage maximally for male mice to help hopefully avoid some of those additional issues. You also can't combine male mice from different shipping containers, and you don't really know how those vendors are going to be shipping those animals in those shipping containers. So you might actually not be able to divide your animals as evenly as you're anticipating either, just based on that. Lastly, health issues also are going to require separation. So if I have an animal that's starting to become a little sick, needs to be separated so that it has easier access to food and water, it's going to be an additional cage space. So just to kind of break that down as a little bit of an example, if I have a standard study, I'm fitting 5 animals per cage, whether they're male or female. Even if I have 1,000 animals, mathematically, I'm anticipating needing about 200 cages. Realistically, that's probably what I'm going to be using. Whereas in our lifespan study, if I'm doing 3 to 5 animals per cage, depending if they're male or female, even with our 1,000 mice, 500 male, 500 female, math-wise, maybe we're looking at about 267. Realistically, however, that worked out up to about, in this study at least, to about 380 cages that we actually needed. And this was only also during the acclimation period, so not when there was additional fighting even thereafter, or when these health issues started that required any of these separated animals. So again, a lot of it isn't very intuitive if you actually think about what the typical young animal studies are. So if we're thinking about also with that, bringing in 1,000 young mice, maybe not that big a deal. We have plenty of staff that can work with young animals, and it's pretty straightforward. However, with the aged mice, it's quite a bit different. So again, the key with a lot of this is that we have to have that experienced staff that know how to work with these geriatric animals. It's not like in an aged animal or in a young animal where maybe we don't have to worry too much about body weights immediately or things along those lines, or health issues right off the bat, but here you absolutely do. So intake weights are very important, which I'll touch base on later, but also we can absolutely anticipate having some health issues right from day one. The vendors often do evaluate the animals to see if they'll be okay for shipping, but male mice can fight in transit. Again, especially if you have very experienced staff, they well may be able to actually catch the subtle little signs of that animal starting to not do so well that maybe even was missed by the vendor. And just to help these staff be efficient for all of these cages that need to be brought in, if you look on the right, that extended down the whole hallway and is in piles that's taller than some of the staff there. But just to make their life efficient, prepare cages ahead of time, knowing, again, you would need some excess, and understand how you're identifying animals. So if you're going to be ID tagging them by their ears, again, have all of those organized and things along those lines so they can be efficient. What helps us also with that in our facility is we work with 3 different software platforms that allow us to really organize everything for these long-term studies. It may not be as necessary for something like a 30-day oncology model, which is a little bit more straightforward, but again, here we're working with years' worth of a lot of information. So Team Gantt, I mentioned previously, is a scheduling software that we use and also to work with our capacity planning. Enos is another program that lets us do our colony health and inventory management. So that really lets me know exactly where every animal is at every time, what's been done to that animal, has it had any health issues or received any treatments, or even in this case, this software lets us track their body weight, tells me if there are too many animals in the cages, or even how that body weight has changed from that animal's previous weights. Lastly, then we use eLab Journal, which is a digital lab notebook that we can also use for our data management. So the last little thing I want to touch base on here is just study endpoints. So typically we can consider humane and scientific endpoints, and in either case they should be well-defined and objective. Aubrey, of course, spoke in a lovely manner about the fun science that we're tackling here, so I just want to take a couple minutes and talk about the humane side of things. And in that these should really not be death as an endpoint studies. And what I mean with that is that those animals have to experience a natural death. Even if they're moribund, we can't intervene with euthanasia. And there's several reasons why we should consider that they really shouldn't be death as an endpoint. And to help us avoid that, there's a couple things we can do. So we can set up intervention points, and we can set up humane endpoints. So intervention points are predetermined and objective criteria that when an animal reaches certain clinical signs, like maybe something like 10% body weight loss, we can start intervening and providing things like supplemental foodstuffs or anything to start help minimizing pain and distress so that we can also have that animal on study a little bit longer. So if we take, for example, an animal where maybe we found that it was starting to develop a tumor that was maybe impacting its ability to walk a little bit, and staff noticed that that body weight was starting to drop just a titch. Well, all right, we've reached an intervention point. We're going to start providing some supplemental foodstuffs and monitoring that animal a little bit more closely. That might extend into some humane endpoints, though, where now we've reached those same or similar predetermined and objective criteria, but we're at the point where really we can't avoid that pain or distress any longer without something like euthanasia. So considering our animal with that tumor, it's now become so large it really can't walk anymore, it can't have access to food and water, and it would inevitably die on its own. Instead, what we're going to do is euthanize it. So not only is this nice for the ethical considerations from your oversight committees and considering the 3 Rs and that side of stuff, and of course for the side of the compassion of the animal, but tying a bit into the scientific endpoints, it also allows you to have a lot more viable samples that you can work with. So if we're looking at a death as an endpoint study where that animal actually had to die on its own, maybe I'm finding it a few hours later, maybe it's now also been cannibalized by its cage mates. I'm losing the opportunity to really use a lot of those tissues or blood or anything like that to evaluate some of these metrics that we're interested in. So instead, if we can euthanize these animals, then I absolutely have all of those tissues, the blood, the samples available, so I can get all that much more data and make this animal's contribution also all that more worth it. Transitioning now, we'll switch a little bit into the animal health considerations that have kind of been tailored to already in some of the other ones. But I'm going to start with barbering. So barbering is typical, like we absolutely see in young animals, though it can be a little bit more severe. Absolutely occurs in males and females. So on the right, we have a little cage of females, whereas on that left, we have that cute little male. While this isn't a typical health concern that actually requires medical intervention, it's an important thing for a staff to be familiar with, and mostly actually how it pertains to their hierarchical society that mice establish. So if I have that cage of 5 females, and I need to separate a couple of them out for fighting or health reasons or any reason really. I want to be able to pick 2 mice, for example, that are of the same social standing so that I'm hopefully not creating or inciting new issues in that original home cage or even in that cage that I'm separating those animals to. The next is malocclusion. So that's just an irregular alignment of the teeth. And so mice have 2 upper incisors and 2 lower incisors that are rootless, so they continuously grow. And the Jackson Laboratory inherently reports a 0.05% of incidence of this anyway in this strain. But there are several factors that can really contribute to this becoming more severe, if not managed appropriately. One of those things absolutely can be diet. So we rely on a normal standard chow in mice to really wear those teeth down as our main function for that food as well as providing nutrition. But a lot of lifespan studies do actually use treatments in the food, including actually in the LEV study. It makes sense, right? Less labor, less stress on the animals, but we do have to consider what that formulation might actually be doing to the firmness of that diet. So if it's at all playing a role there where it's creating that diet to be more soft or more crumbly, then we're at risk for developing more severe malocclusion. So a lot of these health issues, one of the big overarching themes is also if we can catch it early, then we can intervene early and the prognosis is much better. So if we're able to catch it early, like in that top picture, we can still intervene, cut those teeth back, be able to monitor that animal and hopefully regain a relatively normal alignment. However, if staff aren't aware of this or aren't on the lookout for it, it can become quite severe and progress to the extent of in that bottom picture, for example, where that lower incisor has curled up and is now impacting the soft tissue, and that upper incisor is curled all the way back into that hard palate. And that absolutely at that time would then be a cause for euthanasia. I mentioned originally that intake body weights are very important, and this ties very much into the acclimation period that we have for these animals. So this was a lot of the work that we initially did when these animals first really became available in determining the best practices for working with them. But with standard young animals, maybe you can get away with the 24 hours or up to even a week of an acclimation period. With these old ones, we've really found you need at least a month to allow for both weight and behavioral stabilization. And when we think about that acclimation period, it's different for the male mice as compared to the female mice. So with male mice, we worry about fighting and mouse urologic syndrome, which will be what I talk about next. With females, we actually worry about dehydration. So it turns out that they're not very good at adapting to different watering systems. So if they came from a facility that has an auto watering system, but your facility provides water through water bottles, they might need help through that first month while they sort that out. Then coming to the body weights. So on this graph here, we have body weights on the right and then weeks in the study on the bottom. And while this study actually did have 2-month acclimation period just in our study design, even if we just look at the first 4 weeks here, we can see that for both males and females, we see an initial little drop and then it stabilizes out. So this is where the intake weights really come in, because we need to actually be able to make sure that this pattern holds true and that we don't have animals that are falling outside of this pattern, which may indicate that they actually have more of an issue. And these body weight drops can actually be relatively significant in terms of anywhere between 5 to 10%. So it can be quite important for staff to realize, just so that, again, we can be keeping an eye on these sorts of things. So as I mentioned, male mice, we worry about fighting. So it's absolutely expected. There's no way we're going to be able to avoid it. And as alluded to, absolutely is a need for extra cage space, absolutely is a need for additional staff, labor, and monitoring. And as many of these other health issues, as I mentioned, if it's not caught early, can be quite severe. And the main difference between our aged males and our young males that also fight is that the secondary effects of fighting with the male mice can be much more severe, as it can be very much correlated with mouse urologic syndrome. So what happens here is there's a proteinaceous buildup in the distal urethra. So in that picture on the right, you can see the prepuce is a little bulged, and there's actually a little bit of a yellow urethral plug that can be seen, which on the other picture has been manually expressed. And this can be such an effect on the animals' numbers, actually, that I would highly recommend that we actually start with additional male mice so that we can get through the acclimation period from ones that have struggled with this to start the study with the actual anticipated number that we were aiming for. But this is quite a laborious event that can occur, where it includes daily evaluation of these animals and ensuring that they can be able to urinate. Manually expression of these urethral plugs in severe cases where these plugs are severe enough that it's completely blocking the animal from urinating. We may have to also even intervene with cystocentesis to relieve the pressure on that bladder. Now, in this LEV study, this came to about 15% of the mice that were being evaluated in the beginning of the study daily. So you can just imagine how much of a labor addition that is, even for your experienced staff that you have available. The prognosis of these animals is also much worse if they're also affected with anatomic deformities from fighting. So here we have just a couple of examples. So all the way far distal picture, pretty mild compared to these other two, but also still severe wounds to that prepuce. The middle picture, we've now actually developed permanent paraphimosis secondary to these fighting issues, and whereas all the way this picture all the way over on the left, where the prepuce, the normal anatomy of the prepuce can't even be recognized anymore due to the fighting issues. So if they actually are able to move forward through this acute stage of the MUS, then they actually really can develop permanent changes secondary to this. So that animal in the middle, for example, would thereafter have permanent paraphimosis that may cause it to have some additional health issues. Ulcerative dermatitis is on the flip side a little bit more of a female mouse issue. So this is a pruritic dermatitis where these animals really just kind of scratch themselves to bits and cause self-mutilation, fibrosis, necrosis. It's idiopathic, so we really don't have a good reason for why this actually happens. But importantly, it's non-infectious. And also importantly, it's a very inflammatory process. So if I have an animal that was euthanized and it has lymphadenopathy and it has splenomegaly, but it also happened to have ulcerative dermatitis, I might need to consider that that was possibly secondary to that rather than another disease process. This can be one of the most important welfare issues in lab mice, with a reported prevalence of anywhere between 4 to 20%. And as many of these other health issues, absolutely can increase labor and increase animal number needs. If we catch it early, however, like in that picture on the top where we just have some mild scabbing between the shoulders, absolutely we can intervene with things like nail trimming or topical treatments and have that animal be able to resolve, though very much it can recur. But if we're actually having lesions that are a little bit closer to the flank, like this animal on the bottom, which is that same animal, not only are they scratching, but they're also chewing at themselves. So it can unfortunately progress pretty quickly to the extent of them actually then requiring euthanasia. The last little thing I want to touch base on here is actually maybe what I consider one of the most important metrics of the animal health monitoring, which is body condition score. So it's essentially the animal version of body mass index, but it's super quick and easy to do, and I would argue really should be done in any animal anytime it's being handled on any study, but particularly in these. So for that, we just use this little scale from 1 to 5, 1 being the mouse is super under-conditioned, 5 being the mouse is super over-conditioned, and 3 being ideal. So just want to walk us through a little bit of a case study that really exemplifies why this is so crucial. If I have a normal mouse lung study, oncology model, what have you, body weight monitoring really is more than sufficient. So let's, for example, take that theory here. So here we have mouse number 5614. We note that in the beginning we have a little bit of weight loss, which we're anticipating from acclimation, as we've discussed. Then the weight stabilizes out a little bit, and then really starts to increase. So if we're just using body weight metrics, we might be anticipating that this animal is doing quite well. However, if we now also involve body condition score, it's around just after that 10-week mark that staff noticed that that body condition score was starting to go down. So we reached one of our intervention points. We started providing supplemental foodstuffs, supporting this animal, being able to progress it on study a little bit longer. However, did eventually reach human endpoints for needing to be euthanized. And on necropsy of this animal, we found that the liver weighed 9 grams. So that's a pretty outstanding 30% of this animal's body weight. And so that graph, that weight gain, is not actually the animal itself. That's liver mass that's gaining there, while that animal itself is actually declining. So this is where I feel that it's really important that not only do we want to do sound science and ensure that the science really is robust and important for these animals, but also that we're considering the animal welfare side of things so that we can make sure we have viable endpoints both humanely and scientifically, because really they really allow us to do quite a lot in this research community where we really would not get very far without them. So just in summary, really there's an intentionality that's required for these things that are normally straightforward, so even things like diet formulation or test materials that might be needed. Considering the staff experience and just even the emotional and physical toll that it can take on them, and being sure that we can support them throughout these studies as we do the animals. And then that young and old mice are not yet the same. Of course, that's our eventual goal. However, until then, we need to realize that we have to be treating them a little bit differently and handling them a little bit differently. That being said, thank you all very much. Thank you, LEV, very much for allowing me to speak here today and for running this exciting study. Of course, the entire team at Ichor, and then very much so the Jackson Lab with the things that they've developed, as well as the animals themselves. Oh, that's yours.
Well, so, I mean, honestly, you know, I know there's quite a lot of people in the audience who, like me, have not had direct experience of, you know, being trained to do any experiments, or certainly not mouse experiments. So I really, you know, every time I hear about this, it blows my mind how much skill, how much expertise, how complicated these things are. And as you've heard, the RMR study is as complicated as it gets. So, you know, anyone who was thinking, why does such an experiment cost $3.5 million? I think you can now see how extraordinarily good value for money we are getting by using people with the kinds of skills you've heard about. So we've got a couple of minutes for questions.
So with regard to the endpoints of the study, I am reminded of the differences between human lifespan and health span that often exist. And I'm curious in this respect, with regard to the mice, could there be situations where the mice may be suffering severely, but they could linger for a few weeks or even a few months? And in those cases, are you able to distinguish between those situations and situations where the mice will die imminently, so that one doesn't pull the metaphorical plug on the mice that are likely to linger on for a while, even in a poor condition?
Yeah, so again, it can be quite difficult with these animals, because I think one of the most surprising things that I've come from seeing these studies is really that these mice really can live a kind of a crazy long time, considering what's going on with them once we do open them up. So once we identify early that something might be developing in these animals, we start watching them every day. So every day, again, those animal care staff are checking those animals so that we can either, again, if possible, keep them going on the study a little bit longer, or then, if need be, euthanize, so that we can still maintain those endpoints. Again, a lot of the behavioral stuff in the science side we can absolutely discuss further with Aubrey and the possible impact on that in the panel. But we monitor those animals every day so that we can ensure that how that might be impacting them, but also that we're also catching that appropriate endpoint.
Just a quick conceptual question here. So this is a study of life rather than disease, right? And so is there a possibility to somehow reduce the stress levels and make the environment more natural, so that you, in fact, reduce some of those sort of things which, like, for example, put male and female mice together as they are more in a live environment rather than, because it seems like you're introducing a lot of externalities here which are hard to control, especially the stress levels. So this is, my question is there a way to put this experiment in a slightly different way?
Absolutely, great point. So unfortunately, anything in lab animal research, the animals really aren't in their naturalistic environments, though we do try to reproduce that as much as we can using environmental enrichment. Ichor is great. They really allow me to go above and beyond with that, even though it might be a little crazy with the amounts of enrichment I use, but we're really allowing them to express as many of their species-specific behaviors as we can. We also, in our facility, focus a lot on positive reinforcement training and have quite experience working with these aged animals, so that allows us to be able to reduce the stress levels for those animals, at least when we're handling them. Regarding your question of possibly being able to house male and female mice together, not super feasible. Unfortunately, even though they're maybe 2-3 years old, they don't really care, and they would still try to do what they're meant to do in the wild. And then if we actually had to interfere in terms of actually sterilizing those animals, I would argue that maybe that's a little bit much of a variable to try and control just for being able to house different genders together.
Good morning, Danique. So I'm right down the middle.
Okay.
Good morning, I'm Michael. I wanted to ask, as you go through a longevity study, obviously you're doing a ton of intervention for the refinement and the betterment of the animals, which I massively applaud. I'm wondering if social isolation is something that occurs, obviously as you get into a longevity study, you're starting to have animals who get reduced down to a single animal per cage, and if it's something that you notice that has any effect, and whether there's anything that we can do to intervene in that kind of situation.
It's a very good point. So mice very much are social animals, so we do anticipate that, unfortunately, if they have to be single housed, that there is additional stress there. Unfortunately, not something we can avoid. So not only, as you mentioned, in a longevity study, as you get down towards the end of it, a mouse that started in a cage of 5 may well end up alone. Similarly, even in the beginning of the studies, just from fighting or, again, other issues like that, we do end up with animals that are singly housed. That is information that we track in our softwares and things, and something that we considered in our group allocations right at the beginning of the study, so that we could kind of possibly control for the fact that there are singly housed animals already in each group. So we'll see. We're still early. We'll be able to parse apart possibly if there is an effect on that. Unfortunately, though, just something that really can't be avoided, but a very important consideration to have.
Absolutely. And whilst Aubrey was there as well, I meant to ask, do you consider using AI in the result analysis for this experiment? Because then you may be able to factor in more and more things such as the effect of isolation, stress, etc., fighting.
I mentioned that we're looking to collaborate with other groups on tissue analysis. That certainly is not restricted to tissue analysis. If there is indeed some group out there that feels they could do some particularly sophisticated, novel kind of data analysis, then I'm all ears.
Excellent. Thank you very much.
Thank you. Thanks for Danique.